So with this, I will also give some short introduction on the NoSQL. So NoSQL, basically the abbreviation acronym stands for Not Only SQL. So primarily the definition states that it's primarily a next generation databases, mostly addressing some of the points like being non-relational, being distributed, being open source, and being horizontally scalable. And then one of the most important principles in NoSQL is the eventual consistency. I'll also talk about that in the next slide. And apart from that, the key features are asynchronous replication and sharding. So asynchronous replication will help to replicate the data across multiple servers without user intervention or client intervention. And then sharding will help us actually to distribute the data into multiple nodes in a cluster. And then elasticity, scaling up and scaling down is pretty easy with the NoSQL data stores. They are shared nothing architecture, so we don't have to invest on expensive shared storages. And the two principles, base and cap, I will be talking about in the next slide. The cap theorem basically talks about cap C for consistency, A for availability, and P for partition tolerance. So the cap theorem states that you can pick any two of the three. So that means if you are picking consistency and availability, then we need to compromise on the partition tolerance. And if you are picking consistency and partition tolerance, we need to compromise on availability, and same as for availability and partition tolerance. So basically consistency means we need to have a common state across multiple nodes. And availability means system is designed and implemented in such a way that it allows to continue to operate even if one of the node goes down. And partition tolerance includes that if you have a huge network of nodes, dynamic and addition of those extra nodes will not harm the existing already running system. The theorem says that basically available indicates that system does guarantee the availability in terms of the cap. The availability in cap is applicable in the basically available. And the soft state indicates that the system state may change over time without even an input. This means then, for example, if the data is replicated and if you are modifying one of the value in one of the node, the other node will get modified. The data in the other node, the replicated data in the other node gets modified after a certain amount of time. Okay. This also indicates the eventual consistency, so that the consistency will be arrived over a period of time, so that because the replication takes time. So there are a couple of NoSQL storage types. One of the fundamental one that started, the initial one is the key value or tuple kind of store. There are multiple vendors in this area: Redis, Voldemort, Tokyo Cabinet, and Dynamo. And then the columnar stores, we talk about Hypertable, Bigtable, HBase, Cassandra, React. This is not a complete list, of course. We will be talking about some of the few examples. And then document-oriented store is primarily the CouchDB and the MongoDB. And then graph-oriented stores include Neo4j, FlockDB, Infinite Graph. And if you have object stores, where primarily the Gemstone and Oracle Coherence are typically examples of the object store. The XML databases exist, and Oracle are two XML databases. If you go to this NoSQL database.org, you'll find about 150 plus NoSQL DBs listed. So we need to be very careful in picking up also a right NoSQL for a particular BIR or for a particular application. Okay. So the benefits of the NoSQL includes horizontal scaling. So basically adding nodes should never be a problem. So the partitioning of the data should be done, and the data needs to be redistributed to other nodes in a more seamless way. And then the data schema is basically it's a schemaless. So even if you take key value store, documented store, graph store, all of them are basically the schemaless. So the idea is that we don't have an overhead of migration of the schemas when we are actually introducing a new version of the databases. And also the development becomes faster. And also no limited overhead of relational constraints. So we don't have to really have relational constraints. Typically we don't have at all relational constraints. But of course, we can introduce some other relation constraints in, for example, graph database. But I would say we can actually leave this overhead to applications which are actually accessing the data. And the large tables. So we, one of the important behavior of the NoSQL is that we can have columns ranging in thousands. Okay, so especially the big data, big table stores, they actually can store lot of tables, lot of columns. And then this helps, in fact, the longer list of columns helps in denormalization of the data warehouse. And then the faster data ingestion. So because it's a sharding, the data goes pretty fast to multiple nodes in a distributed way. And the other set of NoSQL benefits are basically here we talk about distributed reads and writes. If you look at traditional RDBMS and NoSQL, if you see the picture, the distribution of this data writing is happening in such a way that the client is using the sorting technique. It will automatically distribute the data to appropriate node. So in case of RDBMS, the RDBMS server have to take care of this distribution. And then the batch processing can be done very fast with MapReduce, and runs on one of the most important behavior in the NoSQL is they can run on commodity hardware. And the plug and play and dynamic clusters is one of the most important features. And the development becomes quicker because schema-free behavior, and as was also because we actually don't have the SQL there. So SQL becomes more complex. Okay. The next one. So I'll be talking about some of the NoSQL stores, the behavior of the NoSQL stores and features of the NoSQL stores. So if you take a look